Good morning, everyone. Cool. I'm Richard Miller, and I'm going to talk to you today about the service container, and we're going to go a bit beyond just the basic stuff. So a bit about me first. I'm a software engineer at SymfonyLive UK. I've got about 8 years commercial PHP experience now. May or may not know me as Mr. R. Miller on Twitter. Okay, so PHP applications now, we've moved on quite a lot from how things were. It's no longer this sort of tangle of code, sort of spaghetti code that's really difficult to work with and not testable or reusable. And one of the big things that's got us there, I think, is especially with Symfony too, is like we're adopting the principles of dependency injection and just instead of instantiating all our dependencies and things and not being able to change them, we're moving to making all the dependencies for a class explicit and injecting them in. And when we're in control of the code ourselves and writing it, then it's great. We can just make sure that they're going in through the constructor. We can write setters to inject those in. And then doing this and working with service container is pretty straightforward. But unfortunately, this isn't always, we're not always in control of the code. Quite often you're working with code that's, you might want to work with library that's, it's cool, it does good stuff. You certainly don't want to be rewriting it, but it doesn't necessarily follow these paradigms of good code that we have nowadays. It doesn't deal with its dependencies nicely. It doesn't let us just use straightforward configuration to get into the service container. And the thing with these is we don't want to let some of the less than ideal practice in these libraries sort of infect our code. And if we can still get it into the service container, then we can inject those services into our class, and so our code can still be nice. It can still have its dependencies injected nicely, but because once it's in the service container, we're not so worried about the state of that code, how it got in there. So, which is good, but in order to achieve this, we can't always just use the straightforward configuration that we could with our nice code. And so, so today I'm going to sort of talk to you a bit about the sort of trying to get the most out of the service container, some of these additional options, things that we can do to work with some of this other code, and also going to talk a bit about ways that you can reduce the repetition in the configuration, because just like as when we're writing code, we don't want to be repeating ourselves all the time. Sometimes you find that in the configuration you're injecting the same services over and over again into different things, and it would be nice to be able to reduce the repetition there as well. And also going to take a bit of a look at the compilation process that the container goes through and how different configuration is loaded and the different ways that you can work with it, because by sort of having a look at why you can do certain things in certain places and not others. Okay, so we'll start just looking at some of the options for actually injecting the dependencies in the first place, and maybe just sort of review the ones that we know already and have a look at a few other things. Okay, so constructor injection. This is, pretty common. If you're in control of the code, then we can pass our dependencies in to the constructor, a bit of XML configuration, so defining our service, class, and the constructor argument. We're going to pass in a mailer service into the constructor. And you might still get to do this sometimes with the other code that you're working with. And also, you're not limited to just, I must use this to inject a service. any constructor, you can set any of its constructor arguments. So it might be that it just takes a load of parameters in order to set itself up, but you can still do this using the constructor arguments, just because we want to use them nicely to inject dependencies ourselves. It doesn't limit what you can actually do with it when you're working with this other code. So when you do have a choice, constructor injection is good for, because you know that the dependency is being injected. There's no nasty surprise when you come to use it somewhere else in the code. And you also know that once it's been injected, that's it, it's done. So it's fixed for the life cycle of that object. It's not going to change. OK, so the other thing that we might use more commonly as well is setter injection. So instead of a constructor, we're passing it into a setter. And slightly different syntax in our configuration. So instead of the argument, we're saying that we're calling a particular method and the argument for that method. So this is good if it's an optional dependency, because in that class, if you don't want to take the option to inject something, you can just leave off the call. It's fine. There's a few things to bear in mind, but because it's this method, someone could call it again elsewhere, and the dependency might change. And you can do something about it. Obviously, you can put a check into the method, but it's something you need to do rather than the constructor taking care of it for you. But again, you can use this to call any method. So if you're working with a library that's, once the code is constructed, it's got, say, an init method that actually does stuff to set it up, then you can call that from the container and still get that class in there, call the init method. You don't have to use it in this way to inject dependencies. So another thing that we've got then, as well as constructor and setter injection, is injecting into the public properties of a class. And again, they're slightly different syntax, but it's pretty straightforward. It's property, name of property, what you want to set it to. Now, if you're in control of the code, then I don't really recommend using this, because it's similar to setter injection in the way that you can set it's optional but you've got no control over it. It's public property. It can be changed at any point in the life cycle of the object, and also there's no way of type hinting it. So then you've got to start putting manual checks in to make sure you've got the right. That you've got the dependency that you expected, so it has the right interface. But when it's not your code and you're, say, writing a bundle to integrate a library, so in this case, yeah, we're using a sort of newsletter manager library, then it may just use public properties. And this, so the option's there to work with them. You're not limited because it's a bad idea, so you can't do it. But if you can avoid it, don't. But if you're working with code that uses public properties in this way, then you can still work with it from the container. OK. So this is great if you're working with classes that are just instantiated directly. But sometimes when we're working with these other libraries and things, you might find that they use factory methods or classes to create objects. And so we can't just add a service as we were doing before and have the service container instantiate it for us. We need to actually be able to use the factory to call it. Now, but this is fine because the service container can accommodate this. It's really not that much more complicated. So yeah, so let's say that in our newsletter manager library that we're trying to integrate, they've moved away from just being able to create it directly and put a static factory method on the newsletter manager itself. So to get a newsletter manager, we can no longer just add a service, say this is the class, and the service container, first time you ask for one or inject it in something else, we'll create it. We actually need to be able to call this method. So Fortunately, this isn't a massive problem because there's a few extra attributes that you can add to the service definition, and So as well as specifying the class, what we can do is specify a factory class and the method, and then the service container will know that the first time that you want to use this service, it needs to call the static method of the class itself in order to actually obtain a newsletter manager. And it's not in my example here, but you can also choose to pass arguments through to that as well, so you're not limited to just the call as it is. You can work with anything else that needs to be passed into it. Okay, so that's, yeah, the sort of static factory method. Now, let's say, the maintainers of this library have realized that we're not that happy using static methods because, they're a bad thing. And they've also realized that having the newsletter manager itself deal with its own creation is not ideal. It's breaking sort of single responsibility principle, all these sort of things. So they've moved to using a separate factory class. And it's not a static method anymore. So we need to actually have an instance of the factory class in order to be able to create the newsletter manager. Again, we can deal with this with just a few changes to our configuration. So the key here is that because we need an instance of the factory, then we can create it as a service itself, because that's what the container does for us. It creates instances of services when you need them. So we make the newsletter factory itself a service, and then refer to that service. So instead of factory class, we're using factory service attribute and the method again. So now when we request or inject a newsletter manager into something, the service container knows that it needs to use the newsletter factory service. So if that doesn't already exist, it will create a newsletter factory for us, and then call the create method on. So like we have, so there's more than, just those simple options. If you're, when you're in charge of the code, you can make sure we don't need to necessarily worry about using factories and things anymore, because the jobs that they would do will mostly be done by the service container for us. But other people's code may still, may be using them and things, so you can still use those with the container. And you can deal with things like injecting into properties and calling any random methods it does and things like that. Okay, so one of the things with writing all this configuration is sometimes you can end up with a lot of configuration. You can end up with sort of repeating yourself a lot, calling the same methods over and over again. And just as, we want to reduce repetition in our code, we'd also like to reduce that repetition in the configuration, and then can manage, if we want to change what the service we're injecting into something, then we can just change it in one place. We're not having to search through and find sort of 10 different places where we're using it. So there's a few ways of doing this, and I'm actually going to start by talking about one that you can't do using the Symfony 2 service container. And the reason for that is that you used to be able to do it in an earlier version of it, when it was still in beta, before it became stable. You could use it, so it's interface injection I'm going to talk about, and you used to be able to use it. So I'm going to talk about that partly because to explain why it was removed, and partly because I think talking about that and then talking about what you can use, parent services, sort of highlights some of the principles of dependency injection. So, okay, yeah. So the wrong way with interface injections. This is, on the face of it, it seems cool because we can, reduce the configuration, but there's some fundamental issues with it, and this is why it has been removed. Okay, so what is interface injection? So basically, in order to use this, we need to define an interface on the class. Interface is a good thing, so we know what, we can define the public API for class. So in this case, we're using setter injection, we're injecting the mailer with the setMailer method, and we're using the interface to enforce that it has it. And then in the configuration, you could set, add an interfaces section separate from our services section and say, for this interface, this is the service that I want to inject. And then every service that you create, where the class has this interface, will automatically get the mailer injected. And then you no longer need to specify it for each of those classes. If we've got 10 classes that implement this interface, then we don't need to specify it 10 times. We can just do it once for the interface. And then, however, there's some sort of fundamental problems with this. Essentially, what we're doing is tying ourselves back into the implementation in the code, becoming part of our configuration. We're no longer making a clean separation between the configuration and the code itself. Because the problem is, if you're, say, have 10 classes that implement this interface and you're using it to inject that mailer, then what if you want 5 of them to have a different thing, 5 of them to have one particular mailer, 5 of them have an alternative one? Then you can't do this easily. You'd have to actually go into the code and say, well, these ones now have this interface, these ones have this interface. And as soon as we're having to make changes to the code rather than just the configuration, then it's not so reusable anymore, because in one project you might be, well, I want to use this interface, and another, a different one, so that you can control what goes into them differently. And then you have a problem, because you can't just reuse them. You're having to maintain different versions of them with different interfaces. And also, with we're using setter injection, so we can use, these can be optional dependencies. So if you say, well, one of those, I don't want to inject it at all, then you can't easily do this. You have to go into the code and say, actually remove the interface. So again, we're losing that clean separation. What we want from dependency injection is to have our code over here, write the configuration that wires it all up together, and be able to just make changes to the configuration without touching the code. So from project to project, you've got that ability to wire it up differently. Okay. But what you do have in this container is this concept of parent services, and they let us achieve something similar, but without the problems that were caused using interface injection. And they let us reduce the configuration burden. We can use the parent services to reduce that repetition, but we're not tying ourselves into something that can only be changed in the code then. So just as in the code, we might reduce repetition by saying we're going to extend from an abstract class. So we've got multiple things, multiple classes that have the same setter methods. We're having to add a mailer and an email formatter in this case into the classes, and we've got several things that want these, so we can pull out those methods, pull them into a parent class, and save the repetition. Then we can also do something similar in the configuration. So here we have a couple of services. So at the top, there's an abstract service. And this has the method calls defined on it. And we're marking it as abstract, which means that you cannot directly inject this service into anything else, and you can't ask the container for it. If you ask the newsletter mail manager directly from the container, then you'll get an error. But what we can do is have other services inherit from it. So we have the newsletter manager and the greeting card manager, and so these are the real services that we can take. And then just with this attribute, say, that they inherit from the service at the top, the newsletter mail manager, then when you request one of these services from the container or inject it into something else, then they will inherit those setter methods. Those will get called during the creation of that service. So then we can start to just have one place that defines those setter things and inherit from it for our other services. But the good thing with this is that we can make changes to this just in the services. We don't need to worry about making changes in the code. So if we have a newsletter manager where we decide we don't want the email formatter at all, and we want to add an alternative mailer into it, then we can just change the configuration. We can remove the link to the parent service. The parent service is still there, it's fine, other things are using it, but just in the configuration, we can take out the attribute, and it will no longer inherit the method calls from that, and we can redefine them for that service. And by doing this, we're no longer having to go back in and touch the code. We can make changes purely in the configuration. And then you can reconfigure it from application to application without having to worry that, well, the changes I've made here, when they make it back into this one, are going to break things. Like with this, it's purely in the configuration. And whilst I introduced this with the idea of having a similar setup in the code, there is no direct correlation between them. You do not have to do that. The parent service itself, you can see, is abstract and has no class. So you do not have to have an associated class with the abstract service. You can just create one wherever you've got that repetition and use it to and inherit from it in order to avoid repeating yourself a lot in the configuration. Likewise, just because a class extends from something else in the code, you don't have to create you don't have to create an associated service in the configuration. All we need to sort of think about is what constructor arguments I have, what methods I want to call on it. Where those methods live in the code doesn't matter. And where they live in the configuration doesn't. You can work with them independently of each other. Okay, so one of the things I want to talk about then is how the process that the container goes through when it's compiled and where the different configuration gets loaded into it, why it happens at different stages, and what's happening with it through this process. And through this, you can sort of hopefully start to understand some of, why you can do certain things in configuration and for extensions, and certain things have to be done with compiler passes, and just why you have to do them with a compiler pass and not elsewhere. So. So, if you're using the container as part of the full stack framework, then this all happens for you. So when you make a request and the application sort of boots up, then the container is set up from the various sort of configuration files, from your bundles, extension, from the applications config.yaml. And then it's all compiled down, and part of this compilation process is making it much more efficient. It removes, instead of working with these sort of definitions directly, it gets turned into much faster code that just creates the relevant class, adds any method call setters and things, and returns it to you. But it's not, at the time of requesting the services, it's not looking for parent definitions or looking for alias. All this is, through the compilation process, all this is kind of complexity is removed and it's made very efficient. But if you're using the component standalone in an application, or if you're sort of integrating into something else, then this all happens, but you need to be aware that it only happens when you actually explicitly call the compile method on it. Okay, so if you've sort of worked with Symfony 2 as a framework and made a bundle, then one of the things that gets created in the dependency injection folder of that bundle are these extension classes. And in there you can load configuration. So when you call compile, like these classes, the load method of the extension class is called, and this is used to actually add or process the configuration for the container. And so in this you can do a lot of stuff. So you can load various configuration files, and you also get access to the overall configuration of the application. So we know the settings that the user's added to that, so based on those you can choose which configuration files maybe to load and pull those settings through and add them into the service containers configuration. So for instance with the aesthetic bundle, there's a lot of different, there's a set configuration file for each of the different filters, and based on which you actually set in your configuration file, it chooses which of those config files to load at that point. And essentially what you do is the method of this extension class gets passed in a container builder. So the container builder, I mean, we talk about the container quite a lot, but often when you're actually working with it at this stage, it's the container builder class, because this has all these additional things for setting up the configuration in the first place, and it's only sort of through the compilation process that it gets merged down into container, which is why you'll see container builder in a lot of places. So in this method, you can do pretty much whatever you want to get configuration into this container builder, whether it's like loading XML files, like YAML files, and working with configuration, and you can manipulate it directly with some of the PHP methods and things it has. But what you can't do in these is know what other configuration is loaded, because you can't say, well, if this other bundle exists and it's added these services, then I want to add these, because you don't know the order that the bundles are going to be loaded in, for one thing. And to enforce this, the container builder that's passed into this method is it's not the one that has some of the other configuration loaded, depending on which bundles have already been, which other extensions have already been processed. It's a fresh container builder. It contains none of this configuration already. So you can do all sorts of complicated stuff to add stuff to it, but what you can't do is manipulate any of the configuration that's already in it at this stage. Okay. So this is where compiler passes come in. So you may have seen these in some use, but where their real power is that it lets you respond to the other configuration. So compiler pass is something you can run. So these run after the extensions have been loaded. So all the configuration that comes from the bundles through those extensions gets loaded, and then a series of compiler passes run. And you can add your own, but whether you're using the framework or standalone, or using so the container as a standalone component, then there's a load of compiler passes that get added and automatically run. And these are the things that actually run through this compilation process. So there's a bunch of them that run checks to make sure that the configuration is fine. So to make sure that you've defined classes for services, that there's no, to look for circular references that are going to cause you problems. So it's at this stage that these are the checks that would raise exceptions that you might see if when you've made mistakes in the configuration. And then there's another load that run after that, which do the job of making it more efficient. They merge down the different things so that if you've got a parent service, say it adds it to the definition of the service itself and removes those abstract services so that they're not sort of clogging up the container when you come to actually use it to start requesting services. And all our parameters are resolved so that when you're asking for a service that takes a parameter for something, it's not having to look it up. These are all sort of resolved and frozen. And then once all this has happened, you can no longer make these sort of changes to it, so that we're really separating the process of configuration, setting up how the service is all going to be wired, from actually using them and pulling things out of it. But yeah, you can add your own compiler passes to as well, so that you can add to this process. And this is where you can sort of respond to further stuff. So one of the main uses of them, but not the only one, dealing with sort of tag services. So even if you've not sort of set up compiler passes to work with tag services, and many of you will probably have worked with them where you've created services and tagged them. So in the configuration for tagging the service, it's pretty straightforward. We've just got the tag itself is just a string. The convention is to use the bundle name, the dot syntax, and then the name of the particular tag. So let's imagine that for our newsletter manager, so we've written this bundle for it, and we've got some we're going to say that you can add different formatters to the newsletter manager, that, so it can format the emails and things that it's sending out. But we want to open up. We don't want to limit them to just the ones that are in our bundle. We want to say that other people can write them, and that they can add them in other bundles, so that another bundle could come along and say, I want these services to be added into the newsletter manager. And at the time that you're processing the configuration for the newsletter manager, so in the extension for the bundle, you can do lots of stuff, but what you don't know is what other services have been registered. So with the compiler pass, then we can work with these. We can find out what other configuration has been loaded. So we need to, so when you're creating a compiler pass, it needs to follow this compiler pass interface, and then the relevant method is this process method. And then again, this gets passed in the container builder, but this time it's the fully configured container, the one that actually has all that configuration. So we can ask it what services it has, and we can manipulate those service definitions. We can do all sorts of stuff. We can change the class that it uses. We can add and remove constructor arguments. We can add extra setter method calls. And then that's what we're going to do in this case. So we get the definition of our newsletter manager from the container, and we also ask it for the IDs of any services that have been tagged. So those ones on the previous slide from another bundle where they'd been tagged to say that they're newsletter formatters. Then the container will tell us what those are, and then we can add an additional method call to our newsletter manager definition. And so it's cool. We can start to manipulate the definitions in a way beyond just that we can do in the configuration itself. And one thing to be aware of here is that you're not getting those actual services and adding them into the actual newsletter manager service itself. We're manipulating the service definition. So we're adding method calls to the configuration just as if we'd added them in the XML. So, but this will only come into play if the newsletter manager gets requested from the container, or if you inject it into another service. If you don't do that during a request, then none of these things will actually get created. It's just the definition that we're changing. Okay, so if you're working with a framework, then the place that you add these passes is in the bundle, the class for the bundle itself. So this is the one that gets created when you generate a bundle and that lives in the root of the bundle. And this contains methods that get called in case of the build. This is a method that gets called early on in the process. So when the bundles themselves are registered with the kernel, then again, we actually take in a container builder. But at this point, this is pre any configuration being processed at all. So take in the container builder, and we register the compiler passes with it. If you're using the container in a standalone way, then just this line here, the container add compiler passes, all you really need to know about it. It becomes up to you at what stage that you add them, providing you do it before you call compile. Okay, so this is all really great. We get all this complicated configuration options, so we can manipulate the configuration in different ways. We can use the extensions to do all sorts of cool stuff. We can use the compiler passes to manipulate it and make these changes to it. And then the compilation process takes all that complexity and really simplifies the container to make it more efficient for you. So this is done by the other compiler passes, the ones that are registered automatically, and just make it so that when you're actually using it, when you're requesting services from it, it's fast, it's really efficient, even though it had all these additional features and complexity. Now, if you're using the... But the thing with this is great, and we can get all these performance benefits, but but they're offset by the actual process of this compilation. If all this loading itself and making it more efficient takes time. So we only get the benefits, really, if we actually then cache the end result, this nicely compiled, fast container. And if you're using the framework, this gets taken care of for you. But just so you're aware, so if you're using the dependency injection component as a standalone component, then this does not happen automatically. This is something you actually need to take care of yourself. But it's pretty straightforward, because in the component there's a class of PHP dumper, which you can pass in the container after you've run through the process of adding all this configuration into it and called compile on it. Then you can use the PHP dumper class to dump this container to a fast, efficient sort of PHP one. There's no XML or anything involved anymore. It's all just done with quick method calls. And so if we do that, we can then cache that file, and so when it exists, yep, brilliant, out of any caching. If it already exists, use it. If not, we'll compile the container. And then for most requests, we're no longer doing all this compilation. We're just using the cached version. So, and another thing that in the framework's done for you is that, well, this is all very well, but as with most caching when we're in development, we want to be able to make changes to it and see them reflected, and we can sacrifice the speed. So, when you're in the framework, if you're in development mode and in development environments, so debug's turned on, then the container won't be getting cached anymore. So it'll be slow. It's one of the reasons that things seem to run slowly sometimes when you're working in development and loading pages, is that all this compilation is happening on each one just to make sure that you're up to date with your configuration. So you can replicate this sort of idea if you're using it standalone. You just, simple as just making a flag and saying, if we're in debug mode, however you choose to set that, whether it's an environment variable, that I don't want to cache the container, I just want to get I want to recompile it every time. And then when you're in production, you can switch to using the cache container. Okay, so we've sort of been through some of the things with the container beyond just the basics, constructor and setter injections. We've looked at property injection, we've looked at using factories for creating code, and when you're faced with, say, a library that uses factories, you can still get them into container, and once we've got them in there, we can get them out nicely and keep our code nice and clean. And had a look at some of the different ways of reducing configuration, repetition in that configuration to reduce the burden, and also a bit of a look through the compilation process. So that's me finished for now. So does anyone have any questions at all?